Good afternoon to everyone.
Good afternoon, sir.
Good afternoon,
Thank you.
sir.
Okay. So, so please write this problem. Find the values of A and B for which x plus y plus 2y equal to 3, 2x minus y plus 3z equal to 4, 5x minus y plus az equal to b. Have a unique solution, many solution, no solution. Solution. First you need to write the augmented matrix. A comma B is equal to 1, 1, 2, 3. Okay. Sri Samchita, are you ready to answer for my question?
Yes, sir.
Okay. So what is the second row? Please do.
2 minus 1,
2 minus 1,
3, 4.
3, 4. Okay. Correct. Next row.
5 minus 1,
5 minus 1,
A, B.
A, B. Okay. So, okay, no, thank you. So this is the augmented matrix. So we need to convert these two elements are 0. Okay, so this is equivalent to so I don't disturb the first row 1, 1, 2, 3. So what is the operation we need to use Harshavardhan? What about your mic? Yesterday you told that there is some problem. Okay. Uddhavan, please tell. What is the
Sir,
translation?
R2 gives R2 minus 2R1.
R2 gives R2 minus 2R1. Okay, correct. Okay, first, so what is R2? 2, 1, minus 1, 3, 4. Minus 2R1 means what? Minus 2, minus 2, minus 4, minus 6. If you add, you'll get what? 0, minus 3, minus 1, minus 2. Okay. So similarly, in place of R3,
R3 minus 5R1, sir.
R3 minus IR1. Okay, thank you, Don. R3 minus 5R1. What is R3 minus 5R? R3 is 5, minus 1 A, B, minus 5 R1, minus 5, minus 5, minus 10, minus 15. If you add these two, you'll get to 0, minus 6, A minus 10, okay, B minus 15. Okay. So next I need to convert this element to 0, okay, using this diagonal element. Okay, so I need some operation. Okay, so Ramya, left. Okay. Prashant Kumar,
Yes, sir.
yeah. Please tell what is the operation we need to use here.
R3 gives to
R3, okay.
R3 plus
Please
2R1,
wait,
2R2.
please wait. Please wait. I will first write. What's the first row? Please tell Prashant Kumar.
1,
1,
1, 2, 3.
1, 1, 2, 3.
Yes, sir.
Yeah, 1, 1, 2, 3. What is the second row?
0,
Ah,
-3, -1, -2.
-2. Okay. Okay. What about my voice? Is it audible?
Yes,
Prashant.
sir. Yes, sir.
ஓகே நீ கொஞ்சம் இன்னும் கொஞ்சம் சவுண்டாக பேசு ரொம்ப லோவாக இருக்க மாதிரி இருக்கு வாய்ஸ்
Oh, yes, sir.
ஓகே நெக்ஸ்ட்
0,
வாட் இஸ் ஆப்ரேஷன் ப்ளீஸ் டெல் R3
R3 gives rise to R3 plus 2R2.
ப்ளஸ்ஸா மைனஸ் வருமா
மைனஸ் தான் சார்.
மைனஸ் ஓகேவா மைனஸ் தானப்பா மைனஸ் R2 கரெக்டா பிரசாந்த்
Yes, sir.
okay what is R3 R3 is 0 please tell R3 0 minus 6
-6,
uh,
A minus 10,
A minus 10
B minus 15.
B minus 15 okay what is the minus 2 R2 0
Minus
0 6
0. Yes, sir. 6 plus 2,
plus 2
4.
and then plus 4
Yes, sir.
okay if you add these two you'll get what 0 0 A minus 8 if you add these two you'll get what B minus 11
11.
okay thank you Prashant okay so now so this is enough okay this is enough now what is the first subdivision first subdivision is unique solution first subdivision is unique solution okay so I think okay I will ask you something okay Avantika, are you ready to answer for my question? Okay. Ramya? Danish Raja? Google?
Sir.
Yeah. So question is, okay, for unique solution, what is the condition? Okay, okay.
We have a unique solution for all the values, sir.
Condition கேக்குறேன் கண்டிஷன் வந்து நேத்து கொடுத்தல
சார் நேத்தி கிளாஸ் கவனிக்கல சார்
சரி ஓகே பரவாயில்லை ஓகே
ஓகே சார்
so Harshavardhan please well
so is it like determinant should be equal to 0
no
okay
sir
Rank 3, sir.
R of A of B
A comma B
R of A comma B is equal
to R of A
R of A
R of A
equal to
is
N
equal to N.
here
N.
N is 3 okay
Yes, sir.
so this is the condition yesterday please check yesterday class video or notes okay so
okay sir
so if satisfy this condition then it is a unique solution so you should tell now for what values of A and what values of B okay suppose rank of A comma B is 3 means what first rank of A is 3 okay rank of A 3 means this element should not be what
not equal to 0
Should not be equal to 0.
should not be equal to 0 okay this element
sir.
should not be equal to 0 because A is what 1 1 2 0 minus 3 minus 1 0 0 A minus 8 so this element should not be equal to 0 okay then only the rank of A is what 3 if rank of A is 3 then automatically rank of A comma B is also 3 because this is a 3 by 4 matrix maximum rank is what for rank of A comma B also 3 okay so First, I'm doing. So A minus B, A minus 8 is not equal to 0. What about B minus 11? What about B?
Sir, it may be a 0 or
It
not
may be or
possible.
may not be.
Very good, very good. It may, so B takes any value. B takes any value. So first you should know this condition, and then you should check it here. Okay. Then only you can write A not equal to 8. Okay, B takes any value. B is any value, arbitrary. Okay. Now A comma B is equal to 1, 1, 2, 3, 0 minus 3, minus 1, minus 2, 0, 0. This is what? A minus 8. Okay, A minus 8. This is B takes any value, B minus 11. B minus 11. Okay, A is not equal to A means A, okay, here, where, here, A minus 8 is not equal to 0 because A not equal to 8. Okay, but B minus 11, okay, B minus 11, is either equal to 0 or not equal to 0. Either 0 or B minus 11 not equal to 0. Because B takes any value. Okay. So therefore rank of A comma B, first rank of A is what? 3, and the rank of A comma B is also what? Okay.
3.
Yeah, 3. So first you should write what is A. Okay, what is the matrix A? A is 1, 1, 2, 0 minus 3, minus 1, 0, 0, A minus
8.
Yeah. So since A minus A is not equal to 0, rank of A equal to 3. And rank of A comma B is also equal to 3 from this matrix. Okay. So therefore rank of A equal to rank of A comma B equal to 3, which is number of unknowns. Okay. So this implies the system is consistent and has unique solution. Okay. Subdivision 2. What is subdivision 2 in the question? Many solution. Okay. So now, UST, what is the condition for many solution? University is not here. Okay, and then Kavimani, what is the condition
The rank
for
of A equal to rank of A comma B,
rank of A equal to rank of A
rank
comma
of
B
less than n.
less than n? Okay, n is here 3. Okay, wow. So so what is the possibilities? Either this is a 3, sorry, this is 3, this is also 3. Okay, wow. But if okay,
Sir, not
this
possible, sir.
not possible. Yeah, this is 2. This is 2. Okay, wow. Or this is 1. This is also 1. So these are the two possibilities. So now think about when rank of A equal to 2 from this matrix.
A minus 8 is equal to 0, sir.
A minus 8 equal to 0. Then rank of A
B minus
is
11 is also equal to 0. Sir.
okay. So if B minus is 11 is also 0, then rank of A comma B equal to what?
2,
0.
sir.
2, sir.
Sorry?
Rank will be
Yeah,
2, sir.
yeah, rank is 2. Okay. That means A equal to 8, B equal to 11. Okay. So in this case, A equal to 8, okay, B equal to 11. So maybe I call this is equation 1. Okay. So from this only I am writing. So A comma B. So please tell what is A comma B. Anyone of them? What is the first row?
1, 2, 3.
1, 1, 1, 2, 3. Okay.
2, 3. 0 minus 3, minus 1,
0 minus 3 minus 1
minus 2,
minus 2. When A
0, 0,
8 will be 0, 0.
minus 8, A minus 8.
That is A 8 means 0.
Yes, sir.
That is
Yeah.
also
Yes, sir.
0.
B minus, this is also
0, 0.
0. Oh, yeah, thank you. And the A is what? A is from
1,
From
1, 2,
yeah 1, 1, 2. Okay,
0 minus 3 minus 1,
very good. 0 minus 3 minus 1. Okay,
0, 0, 0.
Okay, thank you, Paritosh. Okay, now from this you can easily observe that rank of A comma B is what? 2, and the rank of A is also 2.
சார்
Yeah.
சார் சாரி
Question?
சார் சார் கொஸ்டின்ல ஏற்கனவே வந்துட்டு கொடுத்துட்டாங்களா சார் யூனிக் மெனி சொல்யூஷன்ஸ் அப்பனா ஏ ஒன் பியோட வேல்யூ தான் சார் கண்டுபிடிக்கணும்
ஆமா ஆமா. So we need to okay, actually find the values of A and B for which we have unique solution. ஓகேவா? So AB தான் கண்டுபிடிக்கணும். ஓகேவா? So but AB கண்டுபிடிச்சிட்டு first you need to find A and B and you need to justify. ஓகேவா? So you need to justify your A and B will satisfy unique solution. Actually, there is no other way. Okay, va? So I think you are telling that. So finally, we need to find A and B. Is it correct? That is your argument, Arjun.
எஸ் சார்
But that is not like that here. Okay, so unique solution. So under what condition it is unique solution? So we observe that. Okay, we observed that by inspection we found the A is not equal to 8 and B is any value, and then here we are checking. Okay, okay.
ஓகே
So now here rank of A comma B equal to 2 and rank of A equal to 2. So therefore rank of A comma B equal to rank of A equal to 2, which is less than 3. 3 is the number of unknowns. So therefore, the given system is consistent but has infinite number of solutions. Consistent and has infinite number of solution. So what is the infinite number of solution means? We need to mention infinite number of solutions. So from the first row, we have what? X plus y plus 2z equal to 3. X plus y plus 2z equal to 3. Okay, from the second row, 0x minus 3y, or you can write 3 minus 3y minus z equal to minus 2. Minus z equal to minus 2. Third row, everything is 0. Okay, so from this y minus 3y equal to z plus z minus 2.
Sir,
Yeah.
sir, plus 3y, sir. Questionலயே minus y கொடுத்திருக்காங்க. இங்க minus 3 இருக்கு, sir. So minus of minus plus வந்துரும், sir.
இங்க மைனஸ் தான் வருது புத்தவன்.
Yes, sir. questionலயே minus y தான், sir, கொடுத்திருக்காங்க.
எங்க கொடுத்திருக்காங்க?
2x minus y, sir.
அதை பார்க்க கூடாது. ஓகேவா? So okay. So you don't see the question. Only thing you should see here. So from this, I am writing x 1 into x plus 1 into y plus 2 into z equal to 3. Okay, wow. Next 0 into x minus 3 into y minus 1 into z equal to minus 2. Similarly, 0x plus 0y plus 0z equal to 0.
Excuse me, sir.
Yeah.
Sir, may I look into the question 1 minute?
Okay. So I also gave this problem as a practice problem yesterday.
Okay, sir. Thank you, sir.
Okay. So now we got two equations. So from the second equation, minus 3y equal to z minus 2, or y equal to z minus 2 divided by minus 3, or you can write y equal to 2 minus z by 3. Okay. Now I am going to substitute y value in the first equation. So what is the first equation? X plus, okay, that, yeah, I need x. So x is equal to what? From the first equation, x is equal to 3 minus y minus 2z. So 3 minus y is 2 minus z divided by 3 minus 2z. So if you take LCM, 3, you'll get what? 9 minus 2 plus z minus 2z divided by 3. This is your x. So x is equal to
Sir, minus 6z in the end.
Yes, yes. Okay, thank you. So x is equal to 7 minus 5z by 3.
by 3.
Yeah. Okay, this is your x. So therefore, x is 7 minus 5z by 3, and y is what? Y is a 2 minus z by 3, and z is arbitrary. So this will give you one parameter family of solution. Okay, this will give you one parameter family of solution. Okay, and then subdivision 3. Subdivision 3 is what? No solution. Yes, no solution. So you need to find the value of A and B for no solution. No solution means what is the condition? Rank of A comma B equal to, or rank of A comma B not equal to what? Rank of A. So either this is 3, this is 2, this is 2, this is 1. So there are two possibilities. Okay. So now look at the equation 1. So for what values can you tell?
A equals to 8 and B is not equals to 11, sir.
Yes, correct, Rahul. If A is equal to 8 means rank of A is 2. B not equal to 11 means this is non-zero. Okay, if this is non-zero implies the rank of A comma B is 3. Yes, correct. So A equal to 8 and B not equal to 11. So A comma B, please tell the first row, Rahul. 1, 1.
1, 1, 2, 3.
Okay.
0, minus 3, minus 1, minus 2.
Minus 2. Okay. What is the third row?
0, 0, 0.
Okay.
B minus 11.
B minus 11. Okay. Okay. And A. And I'll write the matrix A also. That is 1, 1, 2. 1, 1, 2, 0, minus 3, minus 1, 0, 0, 0. Okay. So here B minus 11 is not equal to 0. So therefore, rank of A comma B is 3, rank of A is 2. So this implies they are not equal. The system is inconsistent and has no solution. System is inconsistent and has no solution. Okay. Unique solution. Yes. Okay. I think we finished this problem. Okay. Next topic is I'll go to the next topic. Vectors. So here we are going to discuss linearly dependent and linearly independent vectors. Okay. So first I will define the basic concepts. A set of n numbers x1, x2, xn are written in a particular order, okay, or an ordered set of n numbers, okay, is called an n-dimensional vector or a vector of order n. The n numbers are called the components or elements of the vector. So a vector is denoted by a single letter, capital X or capital Y. The components of the vectors may be written in a row as capital X is equal to x1, x2, xn, or in a column as capital X is equal to x1, x2, xn. These are called respectively, this is a row vector, this is a column vector. We note that the row vector of order n is, this is 1 by n matrix, and the column vector of order n is by n by 1 matrix. So this is addition of two vectors. The sum of two vectors of the same dimension, if it is n, here also n, is obtained by adding the corresponding components. So this is x, this is y, then x plus y is, should add the corresponding components, x1 plus y1, x2 plus y2, in general xn plus yn. So next is scalar multiplication of a vector. If k is a scalar and capital X is a vector, then the scalar multiple kx is defined by, so you need to multiply by all the elements of capital X by a scalar k. Next definition, linear combination of vector. If a vector capital X can be expressed as capital X is equal to k1 x1 plus k2 x2 plus kr xr, then capital X is said to be a linear combination of the vectors x1, x2, xr. The next definition, linear dependence and the independence of vector. So first I'll define what is linearly dependent. The vectors x1, x2, xr are said to be linearly dependent if we can find the scalars k1, k2, kr which are not all zero, but their linear combination is equal to 0. So then we say that the x1, x2, xr are linearly dependent. Okay. So next definition, linearly independent. A set of vector is said to be linearly independent if it is not linearly dependent, or you can say, suppose the vectors are linearly independent if the relation, that is this relation is satisfied only when all the ki's, that is k1, k2, kr, everything is equal to 0. So then we can say that x1, x2, xr are linearly independent. Okay, so again I will repeat the definition, okay, precisely. So this linear combination is equal to 0, okay, satisfied only when all the constant, okay, k1, k2 are 0, then we say that this is linearly independent. That means what? One is does not depend upon other. Okay. So here linearly dependent. Suppose some of the scalars are not equal to 0, but their linear combination is equal to 0. So then you can write x1 in terms of what? X1 in terms of the other vectors, x2, x3, like this. Okay. So next, when the vectors x1, x2, xr are linearly dependent, then the linear combination is equal to 0, where at least one of them, at least one of the k's, the constant k's is not 0. So let us assume that km is not equal to 0. So the coefficient of km is xm. So you can write xm, okay, is the linear combination of the other vectors like this. So thus, at least one of the given vectors, that is xm, can be expressed as a linear combination of others. Methods for testing linearly dependence and independence of vector. So there are three methods. Okay, if you include this one, there are four methods you can say. The first method is using definition directly. The definition means using this definition. Okay, so this definition directly. So method 2, you should convert the given vectors into row echelon form. Okay, so we write the given vectors as row vectors and form a matrix using elementary row operation on this matrix. We reduce it to echelon form, that is the one in which all the elements in the rth column below the rth elements are 0 each. Okay, so already we converted into this form, but I don't mention the name echelon form. Okay, so when we are finding the rank, we are converting into echelon form. Okay, if the number of non-zero row vectors, again I'll repeat, if the number of non-zero row vectors in the echelon form equals the number of given vectors, then the vectors are linearly independent, otherwise linearly dependent. This is method 2. Method 3, using rank. If there are n vectors, okay, if there are n vectors, each of dimension n, then the matrix formed as in method 2 will be a square matrix of order n. Okay, if the rank of the matrix is equals to n, okay, the rank of the matrix is equal to n, and n is nothing but the number of vectors. The rank is equal to the number of vectors, then the vectors are linearly independent, otherwise it is linearly dependent. Okay, finally this is the easiest method. Okay, if determinant of A equal to 0, then the vectors are linearly dependent. If determinant of A is not equal to 0, then it is linearly independent. Okay, so you can use determinant idea only if it is a square matrix. Okay, if it is not a square matrix, you can't use determinant. Then you need to use okay, this form. You should write method 2. Okay, you should use method 2, or you can use method 1. Okay, so write down the first problem. Show that the vectors x1 equal to 1, 1, 2, 1, 1, 2, x2 is equal to 1, 2, 5, and x3 equal to 5, 3, 4 are linearly dependent. Also express each vector as a linear combination of the other two. Okay. So method 1. Now I am going to use directly the definition. So in method 1, first you should assume that let k1 x1 plus k2 x2 plus k3 x3 equal to 0. So k1, so this is x1. So x1 is what? 1 comma 1 comma 2 plus k2 into x2. x2 is 1 comma 2 comma 5. K3 into x3. x3 is 5 comma 3 comma 4. Right hand side is 0, so I will write 0 comma 0 comma 0. So now k1 na. Okay, first I look next to k1, 2k1 plus k2, 2k2, 5k2, and then 5k3, 3k3, 4k3 equal to 0, 0, 0. So you'll get 3 equations and 3 unknowns. Okay, so what is the first equation? K1 plus K2 plus 5K3 equal to 0. Similarly, next K1 plus 2K2 plus 3K3 equal to 0. So next 2K1 plus 5K2 5K2 plus I think I've done the mistake here. 3K2 yeah, 3K3, yes, 3K3, yes, it is correct. So 5K2, already I write 3K3 plus what? 4K3 equal to 0. So you have 3 equations. Now you need to solve these 3 equations and get the values of sometimes you will get the values, but sometimes you will get some relationship. Okay, va? So first equation is what? K1 plus K2 plus 5K3 equal to 0. Second one, K1 plus 2K2 plus 3K3 equal to 0. And 2K1 plus 5K2 plus 4K3 equal to 0. Okay, so now I am going to subtract 1 minus 2. 1 minus 2 gives you what? I am eliminating K1 from this. So then you will get minus K2 plus 2K3 equal to 0. So this implies K2 equal to 2K3. This is equation 4. Now I am going to substitute K2 equal to 2K3 in the third equation. So if you substitute the third equation, what you have? 2K1 plus 5K2. 5, what is K2?
2K3.
Yeah, 2K3 plus 4K3 is equal to 0. So, or you can write this is a 2K1
plus 10K3.
yeah, 10
Plus 4
plus
K3.
4, 14.
14 K3.
Yeah, 14 K3 equal to 0. Or throughout divide by 2, you get what? K1 plus 7.
7.
Yeah, 7 K3 equal to 0. Or K1 is equal to minus 7 K3. So K2 also in terms of K3, K1 is also in terms of K3. So now I am going to assume that K3 is so some arbitrary value. Okay, you can take 1. Okay, K3 is, I'm fixing 1. If K3 is 1, equation 4 implies K2 is 2. Equation 5 implies K1 is minus 7. So now we know K1, K2, K3. Okay, now what is the first equation we are assuming? K1 x1 plus K2 x2 plus K3 x3 equal to 0. So instead of K1, K2, K3, I am going to replace this value. So K1 is therefore minus 7x1 plus 2x2 plus 1 into x3 equal to 0. So this implies, what is the conclusion? The vectors x1, x2, x3 are what? The vectors x1, x2, x3 are
linearly dependent.
very good, Paritosh. Linearly dependent. Because the definition says what? This definition, the linearly dependent, okay, if we can find the scalars K1, K2, Kr, okay, which are not all 0, such that their linear combination is equal to 0. Okay, in our problem, we are assuming, first you should assume the linear combination is equal to 0. From this, I can find some scalars which are not all 0. So, okay, therefore, this implies the vectors x1, x2, and x3 are linearly dependent. Okay. So, but there is one more question. Okay, also express each vector as a linear combination of the other two. So I think from this you can write. Okay, x1 equal to what? X1 equal to one by 7, or if you take minus 1 by 7 into what? 2x2 plus x3. Yeah, is it correct? Similarly, x2 is what? Minus 1 by 2.
Sir, in this equation, minus 7x1 should be there. Because
Okay,
K1 value is minus 7.
Okay, thank you. Minus 7. So minus 7 means here what?
Plus 1 by 7.
Plus 1 by 7. Yes. Okay. And what about the x2? What about x2? In terms of x1 and x3?
Minus 1 by 2 into minus 7x1 plus x3.
Okay, 7x1 plus 7x1 minus x3. Yeah.
Yes, sir.
Okay,
1 by 2.
7x1 minus x3 divided by what? 1 by 2. Is it
1 by
correct?
2, sir. Yes, sir.
Yeah. x3 7x1 minus 2x2. That's all.
7x1 minus x.
So this is the answer for the second part. Okay. So now method 2. So I am going to convert into a row echelon form. Okay, row echelon form method 2. Okay. So what is the given matrix A? Can anyone tell what is?
Sir, x2 negative liya sir. -1/2.
X2 2x2 now. 2x2 equal to 7x1 minus
Sir.
3. Okay, so x2 equal to what? 1/2 into 7x1 minus x3. Is it correct?
Okay, sir. Okay, sir.
Okay. Okay. So now, please tell what is the matrix A. Purnachandra. 1, 1, 2. First row.
Yes, sir. 1, 1, 2.
1, 1, 2. Second row is what?
1, 2. 1, 2, 5.
1, 2, 5. Third row is 5, 3, 4. Yeah.
5, 3, 4.
Yeah. 1, 2, 5. 5, 3, 4. So now I am going to convert into row echelon form. I am going to convert these two elements as 0 first. So I need some transformation. So who is ready to tell the transformation? Who is ready to tell?
R2 plus R2 minus R1, sir.
So, okay, I will write you here.
R2 plus R2 minus R1.
Yes, sorry. First row, please tell the first row. 1, 1, 2.
1, 1, 2, sir.
1, 1, 2. What you are telling R2 in place of
R2 minus R1.
R2 minus R1. Okay, for my convenience, I will write R2 dash here. I will tell you later why I am putting R2 dash. Okay. Okay. And then here, what is R2 minus R1? 0, 1, 3.
0, 1, 3, sir.
Okay. Next, please tell. What is next operation? In place of
3
R2,
0 minus 2 minus 6, sir.
the one, what must tell the transformation? R3, R2
R3
dash.
minus
R3 minus 5R1.
Okay, R3 minus 5R1. So please tell the elements.
0, minus
0,
2, minus 6.
minus 2, minus 6. Thank you for those. So next I need to convert this element is 0. So 1, 1, 2, 0, 1, 3. Okay. 0, 1, 3. In place of R3, double dash. Okay. So here I'm using second time R3 double dash. Please tell R3 double dash is what?
R3 dash plus 2R2 Sir, dash
R3 dash plus
plus 2R2 dash.
plus 2 R2 dash, correct. Okay. So if you use this transformation, then 0, 0, this is also 0. Is it correct? So number of non-zero row is what? Only 2. Number of non-zero rows is equal to 2, which is strictly less than the number of given vectors. Number of given vectors. We have 3 vectors, x1, x2, x3. So this is actually equal to 3. So this implies by method 2, we can check the vectors are linearly linearly dependent. Suppose if we have this is non-zero, okay, well, this is non-zero, then the number of non-zero is 3, that is equal to a number of vectors, and hence the vectors are linearly independent in that case. But here this is 0, so that's why rank is also 2. The number of non-zero row is also what? 2. So the vectors are linearly dependent. Okay. And there is,
Sir?
yeah.
Sir, if the number of non-zero rows and the number of given vectors are equal, then the vectors are linearly independent, sir.
Yes, the number of non-zero rows is equal to the number of given vectors, then it is linearly independent.
Okay, sir.
Okay. So, and then I need to write these vectors as a linear combination of second particular. We have a second part. Also express each vector as a linear combination of other two. So, for this, I will start here. R3 triple dash. Okay, wow. R3 triple dash is here. R3 not triple dash, R3 double dash, sorry. R3 double dash is equal to or equivalent to 0, because that row is what? 0. Okay. But R3 double dash, you can write what? R3 dash plus 2R dash. R3 dash plus 2R2 dash. Okay. But R3 dash is equal to what? R3 minus 5R1. I think now you understand why I wrote dash double dash. 2 into R2 dash. R2 dash is R2 minus R1. So this is equal to R3 minus 5R1 plus 2R2 minus 2R1. So this is equal to R3, how many R2? Minus 2R2, minus 2R2.
Sir, plus 2R2, sir.
Plus 2R2, okay, sorry. Plus 2R2 minus
7R1.
7R1, okay, yeah, 7R1. Okay. So now, or you can write minus 7R1 plus 2R2 plus R3 equal to 0. So instead of R1, I can replace by what? Paritosh. This is nothing but what?
112.
1, 1.
Yeah, 112 da. But 112 is what? X1. Yeah, X1. Yes, correct. X1 plus 2 into X2 plus X3 equal to 0. So now I think you got the same relation here in method 1. Okay, okay, in method 1 you got the same relation, and then from this you can write like this. So please tell X1, X2, X3 quickly. I will write. What is X1? X1 equal to minus 1 by 7. Minus
1 by 7. 1 by 7 into 2x2 plus x3.
Okay. Okay. Now it is correct. What is x2?
X2 is equal to minus 1 by 2 into minus 7x1 plus x3.
minus 7x1 plus x3. Yeah.
Sir.
Okay, what is x3?
7x1 minus 2x2.
Yeah, 7x1 minus 2x2. Last method, method 3. This is the easiest method. Okay. So this is A is what? 1, 1, 2, 1, 2, 5, 5, 3, 4. Okay, find the determinant. One into 8 minus 15 minus 1 into 4 minus 20, 25 plus 2 into 1 minus, sorry, 3 minus 10. So determinant of A is minus 7 plus 21 minus 7 minus 40. So 21 minus 21, 0. So determinant of A equal to 0. So this implies x1, x2, x3 are linearly dependent. Okay. So I will give you one practice problem. You can try. And but in method 2, you cannot write a linear combination of other two. Okay. So only by using method 1 and method 2 only you can write. Okay. Show that the vectors x1 equal to 2 minus 2, 1, x2 equal to 1, 4 minus 1, and the x3 equal to 4, 6 minus 3 are linearly independent. Second problem. Show that the vectors x1 equal to 1, minus 1, minus 1, 3, okay, and the x2 equal to 2. Write the question fully. Show that the vectors, okay, 2, 1, minus 2, minus 1, and x3. X3 is a 7, 7, 2, minus 7, 4 are linearly independent. Li, short form. Last problem. Show that the vectors capital X1 equal to 1, minus 1, 1 minus 1 minus 2 minus 4, x2 equal to 2, 3 minus 1 minus 1, x3 equal to 3, 1, 3 minus 2, and x4 equal to 6, 3, 0 minus 7. So are linearly dependent. LD. Okay, so again I'll check it. 1 minus 1 minus 2 minus 4. Okay, and then 2, 3 minus 1 minus 1. 3, 1, 3 minus 2, 6, 3, 0. Okay, that's all. Okay, thank you, students. We'll meet tomorrow.
Thank you.